So let's look at solving an inequality. And when we solve the inequality, we need to graph the solution on a number line, and we need to express our answer in interval notation. So we have the inequality of x squared plus 2x minus 15 less than 0. In order to solve this one, we're not really comfortable solving less than, greater than, or anything like that. So first, just go ahead and set it equal to 0. So change it to a 0. So we have x squared plus 2x minus 15 equals 0. Because now we're comfortable and familiar with solving something like this. As you can see, we're dealing with the quadratic, so we're going to have to end up factoring. So by factoring, we're going to end up using our AC method. So our A value is 1, our C is negative 15, so we end up with negative 15. We're looking for factors of 15 that will add up to 2. So I know 5 times 3 gives us 15. We want it to add up to positive 2. So and we can double check. 5 plus negative 3 gives us 2, so we found the factors to work. Because my A is 1, I can take the shortcut that this is going to factor into x plus 5 and x minus 3. If you're not comfortable taking the step, make sure you do all the steps of AC method. So you write down your middle term with 5 and negative 3 and then apply grouping. But because A is 1, we can go ahead and take a shortcut and write it like this. So now it's already factored for us. So if we're trying to solve, we take each of our factors and we set it equal to 0. So from here you can see we get x equals negative 5 and x equals positive 3. So from here, once you reach this point, you take your numbers and you put them in a real number line. So remember, your number line goes anywhere from negative infinity all the way to positive infinity. And we're interested in putting the values of negative 5 and 3. So when we place both of our solutions on our number line, you can see we're creating 3 different intervals. The best way to do this is to organize it in a table. So your table is going to consist of your intervals. In this case, we have one of our intervals is going to be from negative infinity to negative 5. My next interval is going to be from negative 5 to 3. And my last one is going to be from 3 to infinity. Once you have your intervals, go ahead and pick what we call test values. So test values have to be those values that we're going to test, but they have to be within your interval. So we have to pick a value that is from negative 5 to negative infinity, so it has to be something less than negative 5, so we can pick negative 6. For this interval from negative 5 to 3, you have to pick a number that's in between this interval, so a good number would be 0. And then you have to pick a number that's greater than 3, so you can go ahead and pick 4. You cannot use those actual values. It has to be a value that is before or after that value. Then you're going to substitute back into your back into our problem. You can go ahead and do it back into the one that we already factor. So we're going to substitute back into our inequality we're interested in. So everywhere we see x, we're going to replace it with negative 6. So we end up with negative 1 here times negative 6 times negative 3. We're going to end up with the positive 18. Negative 1 times positive 18, we're going to end up with the negative 18. Then this is going to help us make a conclusion. So we're interested in what type of solution this gave us. We ended up with the negative number. So negative numbers are less than 0. So we say our function at this point, at this interval, gives you solutions that are less than 0. Now if we test 0, so we end up with 0 plus 5, 0 minus 3. So we end up with positive 5 times negative 3. As you can see here, we end up with a negative 15. So, I think, let me go back here. I ended up multiplying this, which we shouldn't. We have negative 6 minus 3, so it should be a negative 9. Negative 1 times negative 9 will give us a positive 9. Let me correct myself real quick. So in reality, we should have been going, it's a positive number, so f of x is greater than 0. Okay, now we're back on. So now we have a positive 5 times a negative 3 gives us negative 15. So in this case, we're dealing with a number that is less than 0. And go ahead and test 4. So we have 4 plus 5 times 4 minus 3. So we end up with 9 times 1. So we end up with a positive 9. So we make the conclusion that at this interval, our function gives us solutions that are greater than 0. And then you go back to your problem. Our inequality was asking us to find values that are actually less than 0. So here we obtain values that are greater than 0, so we cannot use this. This is less than 0, so these are the values we're looking for. This one is greater than 0, so we cannot use this one. So as you can see, the only solution here, our interval notation, the only solution will be the interval of from negative 5 to 3, and we're talking about less than, so we cannot use the values. That's why I'm using parentheses. So that's our solution. We can only use those values that are between negative 5 and 3. And you can go, oops, there we go. And you can go back to your number line and you can see the only ones we can use are right here. So we can shade the area right there.